The John M. Asplund Water Pollution Control Facility, located at Point Warrenzoff in Anchorage, is Alaska's largest wastewater treatment facility and is owned and operated by the Anchorage Water and Wastewater Utility. The John M. Asplund Water Pollution Control Facility is also called the Asplund Wastewater Treatment Facility, or simply Asplund. Built in 1972, the Asplund facility has kept pace as wastewater treatment technology has evolved and the demands of the community have grown. It was upgraded in the mid-1980s to a 58 million gallon per day facility. On average, this facility cleans and treats approximately 30 million gallons of wastewater every day, 365 days a year. Prior to the environmental regulations we know today, in the late 1960s, it was common practice to dump wastewater in moving water like rivers. In 1969, the Cuyahoga River in northeast Ohio caught on fire from the pollutants from industrial dumping and wastewater discharge. And that began the push for the Clean Water Act we operate under today. John M. Asplund, former Anchorage mayor, along with city planners, fortunately were forward-thinking and pushed to have this facility built and in operation prior to the mandatory regulations in 1973. All wastewater from Joint Base Elmendorf-Richardson to South Anchorage flows through a series of pipe to eventually be cleaned and treated here at Asplund. Asplund also treats waste from the Mat-Su Valley and parts of the Kenai Peninsula. Septic trucks throughout South Central Alaska empty their loads at one of AWWU's septage receiving stations. That wastewater flows through the same pipe system and is then cleaned and treated here at the Asplund Wastewater Treatment Facility. The influent wastewater pipe is 96 inches. To put that into perspective, the Trans-Alaska Pipeline is a 48-inch pipe. Our influent pipe is twice the size of the Trans-Alaska Pipeline. This is the influent wastewater as it comes into the plant. Influent wastewater is the term used to best describe all the wastewater collected in the pipes, beginning with your kitchen sink drain and your toilet flushes. This is where we pull the first samples of wastewater for testing. We are testing the BOD and the TSS. BOD stands for biochemical oxygen demand. It represents the demand the organic waste puts on dissolved oxygen. BOD is a measure of the quantity of biodegradable organic material in the water and the amount of dissolved oxygen that must be present for microorganisms to decompose that organic matter. Dissolved oxygen, along with organic material, must be present in the water for aquatic life to survive. Microorganisms utilize dissolved oxygen when consuming organic material. TSS is total suspended solids, particulates of varied origin, including soils, metals, organic materials, and debris that is suspended in the water. Turbidity is an optical measurement that indicates the presence of suspended particles, which is a way to measure the degree of pollution in the water. We are going to go through the entire wastewater cleaning and treatment process. We will follow the water flow first and then show how we handle the solids. First, all the influent wastewater goes through large rotating screens during a screening process. There are 3 screens. Each screen is 45 feet tall. There are only 6 of these screens in the world, and 3 of them are here at Asplund. The screens catch wipes, food particles, grit, and other solids. Anything over 6 millimeters is caught in these screens. Asplund removes 6,000 to 7,000 pounds of wipes per day, of which about 500 pounds are removed manually. We will talk more about handling of these solids later. Grit is sand, gravel, and other inorganic materials. Around 1,000 pounds of grit per day is removed from the wastewater. Once the flow has passed through the screens and the large debris, solids, and grit have been removed, The next step in the process is the clarifiers. Originally, Asplund had 3 clarifiers, and in the 1980s, 3 more were added, doubling the capacity for the facility. The clarifier allows any solids that made it through the screens to settle to the bottom, and any fats, oils, or grease, fog, to rise to the top. There is a scum collector on the top which scrapes the fog into a central receptacle, and there is a sweeper at the bottom that pushes any solids into a different receptacle. In the end, primarily all that is left is water. This is an empty clarifier. You can see the bottom is slanted towards the middle. The sweeper pushes any solids to the middle and into the proper receptacle. This is a full clarifier. At the bottom middle, you can see the arm of the scum collector. The scum collector pushes all the fats, oils, and grease, fog, into the scum collector receptacle. Once the solids and fog has been removed, then the wastewater needs to be disinfected. We utilize lots of sodium chloride, basically salt, and lots of very, very soft water to create a brine, and then we run that brine through the electrolyzers. The electricity pulls out the chlorine from the brine, creating sodium hypochlorite, basically a super strong bleach, and that is what we use to disinfect the water. Once disinfection has been added to the water, there needs to be enough contact time to make the disinfection the most effective. That contact time is achieved by having the now cleaned and treated wastewater enter a pipe that spans roughly half a mile. The half-mile long contact pipe is 120 inches. That's 10 feet. You could drive a car through this disinfection contact pipe. After the water has been disinfected and is flowed through the half-mile long 120-inch pipe, it goes through a reverse P-trap system at the beach tower. This helps to maintain proper contact time for optimum disinfection prior to the water going back into the environment. When the wastewater enters the facility before it goes through the screens, samples are pulled for testing. After the entire cleaning and treating process happens, samples are pulled for more testing to be sure we've removed the required level of pollutants. The requirements for our permit are removal of 30% of BOD and TSS. However, Asplund cleans and treats up to 45% removal of BOD and over 75% removal of TSS. This is what the water looks like before it is released into Cook Inlet. Anchorage is home to the highest tides in the United States. It makes for an optimum mixing zone once the cleaned and treated water is returned to the environment. There has been no evidence of the discharge having an impact on the environment. So, what do we do with the solids we removed from the water? Now we will explore that process. Let's go back to the screens we spoke about in the beginning. The 45-foot tall rotating screens catch wipes and other solids. Once the screens reach the top, a brush cleans off the debris that eventually goes to the landfill. This is what wipes look like in the sewer system. They don't break down and dissolve like toilet paper, and they cause havoc in the system. Please don't flush any wipes, even if they say flushable. Just throw them away. The grit travels through a conveyor system and is dumped into a waiting dump truck. The solids collected during the clarification process are pumped back to the main plant to begin the dewatering process. This shows the biosolids which were removed during the clarifier process. They are squeezed to dewater. The goal is to remove as much of the water from these solids as possible before putting the solids into the incinerator. The biosolids are fed into the incinerator. temperatures within some of the hearths of the incinerator can be as high as 1,500 degrees. We are able to take 65 tons per day of biosolids and burn them down to about 5 tons, less than a dump truck full. Anchorage Water and Wastewater Utility not only follows the Clean Water Act rules, we also abide by the Clean Air Act rules. All smoke from the incinerator goes through scrubbers to clean the air and sprayers to cool the air. This process keeps any emissions from the incinerator clean, and unless the outside temperature is extremely cold, you'll never see a plume. The grit, wipes, and ash are all loaded into the same dump truck and end up at the landfill. This shows the wipes, then the grit, and finally the ash is dumped into the truck bed. If we didn't utilize the incinerator, we would have over 8 dump trucks a day taking waste to the landfill. On average, we currently send 1 dump truck per day to the landfill. This dump truck is the final step of the solids handling. We hope you've enjoyed this virtual tour of the John M. Asplund Water Pollution Control Facility. And remember, flush only pee, poo, and toilet paper. AWWU keeps water flowing and wastewater going 24/7, 365.